Well, hello there, YouTube. My name is Tony, and this is TonyLiveTV. And in this video, I'm going to be taking a deep dive into the ISCV, or the idle speed control valve. But it's only got 2 pins. So I decided to dig a little bit deeper into the idle speed control unit. And so that's what this video is all about, is how these things talk together, because they're quite expensive, right? Just to go out and buy one because you think you need one is not the way to do it. In this video, I'll show you how I decided I don't need either one of these things. Let's get going. I'm going to start by loosening this 10 millimeter. Just loosen it just enough so I can bring back the actuator just a little bit so I can remove this plug. I just don't want to put any extra tension on the plug wires. Before I begin this video and start connecting probes and power sources or whatever to this idle speed control valve, I wanted to mention that I've already done a video where I've tested and cleaned this, and you might want to check that video out. But that video really was just your basic test. You're just going to throw voltage across here, listen for it. I mean, this is what basically they do. You can take a 9-volt battery, so you know that your valve's not stuck. So that's one test that you can do, simple 9-volt battery. Another test you can do is to warm up the engine and then go ahead and pull your plug. And if the engine increases, it's doing its job. But if you already have a high idle, that's probably not going to help you. So you have to dig deeper. One test I didn't do that the manual says to do is to do a resistance test and see what we get. 3.98. I'd say that that's right within specs. In my last video, I mentioned that I had a high idle, which is true. And some of you might think, well, why didn't I just start right here? Because this is usually one of the main causes of a high idle. And you're right, that's true, but everything pretty much talks to this. So I wanted to test those things, especially the potentiometer, because I wanted to test it while everything was on the vehicle and all put together. I needed to test the power and everything going to it, the source. Is it sending the right signal back? All that. So that was an important test. And this, we know it opens and closes, really. So here's my first test that's not in the manual. My first test is I'm just going to throw a resistance. What kind of resistance is this? I'm just curious about the number. So I made these pins. As a matter of fact, I have this whole collection of stuff. But there's the resistance between these 2 pins. Now I'm curious what the voltage will be when I turn on the ignition. Well, that one there tells me between 3.1, 3. Look at that. Ooh, look at the changes. Let's look at that with another multimeter. The idle speed control valve, or ISCV, it's just a 2-pin pulse width modulated solenoid valve. That's all it is. And it just regulates the idle speed by controlling air bypass around the throttle plate. So if this is a pulse width modulated signal, let's look at it with an oscilloscope. This next test is also not in the manual. We're going to call this a Tony test. What I've done is I've set my oscilloscope probe. I have one on each one of these pins. So I'm going to look at each of these. Before I forget, click on that like button down below. And if you're a subscriber, thank you for subscribing. I appreciate it. And if you're not a subscriber, consider becoming a subscriber. I'm trying to get as many subscribers as I can before I die. I don't have a whole lot of time left, but I've got a lot of work to do. This channel is 100% dedicated to the 560 SL. All right, so there's my oscilloscope, all ready to go. Let's go ahead and turn on the ignition. Let's see what we get. That's interesting. What you're seeing there is not what I expected to see. What I expected to see really is a square wave. And I expected to see it all the way across, but only on one channel. I have both channels connected, and what I expected to see was one channel at 0 to basically be the ground when the ignition is on. But look what you're seeing. You're seeing variable voltages, and that's not a square wave. Well, maybe. Let's zoom up on it. So there's a steady waveform, and you can see that it's not a true square wave. It just drops off, and this is running right now. It's just a stable, I've got it stabilized, and I'm only turning off the one channel. You can see how an oscilloscope could help, assuming that I know what I'm doing here. The manual doesn't tell you any of this kind of stuff. So this is a live capture with the ignition on both pins. And you can see my duty cycle differences. So we're sitting about 10% duty cycle on channel number 1. But we should see a square wave as far as I'm concerned. And then you see our voltage is 14.37 is our maximum on that side. And then we have 15, which is going to be basically the exact same thing, but in millivolts on the other side. I don't quite understand that. And then you see a couple of spikes on that second channel too, up and down, up and down. You see that? So those are little spikes, and it mimics there on channel 1 a little bit. And then channel 1 starts out nice and straight, goes up, flattens out, but then it curves off. That's not a square wave. So what's causing that? I don't know, and I don't think it's correct. The manual doesn't really tell you about any of this kind of stuff, but I thought it might be useful. And if we change to another idle speed control unit, and the square wave fixes, then hey, we know what it should look like, right? That's the whole idea behind these videos, is I'm taking the whole car apart, put it all back together, and test everything, get baselines for every single thing that I can think of. Easiest and quickest thing to check is a vacuum leak, and I did that in that other video. I did a smoke test, right? Even though I put in new injectors and all that, that wasn't part of this fast idle, because that has no effect on the idle. I just wanted to do that. It was something I had already planned, but at the same time, I wanted to do that smoke test, right? Wanted to make sure they don't have a vacuum leak, because that's what's causing this high idle. And then move on to the potentiometer, because it's there, right? Somebody mentioned something about the potentiometer, so I did a video on it, and we want to check it. That has a sweep. That, on the oscilloscope, you saw that was a sweep. This one here is a pulse, and it should be a square wave as far as I'm concerned. It's a completely different way of modulating that control valve. So let's see what the wave should look like in my head. I'll show you. This is what I expected to see. Something like this, something that's consistent all the way through. There's no drop-offs, there's no curves, there's nothing. This is a square wave, and this is an 80% duty cycle. So you see it's 80% or mostly closed and 20% not. And that's really what I expected to see. And then that upper blue line is channel 2. I expected that to be flat like that. Well, the next step would be to either learn everything there is about the idle speed control unit, which is what is controlling this, or you swap one out. That's kind of what the manual tells you to do. At this point would be to swap it out and then see if your idle goes back to normal. Of course, not everyone just happens to have an idle speed control unit sitting in their glove box. Or maybe they do. I might have one in my glove box. Let's take a look. So here's my little box of things that every 560 SL owner should have. This should be in your glove box. Let's see what we've got. Well, this is a new rear TDC. That's one thing. You know what that is? That's an idle speed control valve right there. And if we look at it, we can see it's tested good. All right, so I have that. Everybody should have, well, I don't know if you should have that. Here you go. This here is an overload protection relay, brand new in the box. New fuel pump relay. And then over here, this is not new. It is an idle speed control unit. That's what the manual calls it. Idle speed control unit. Let's move this box out of the way. Oh, let's see what we've got. So I don't know how I acquired this. This says 88 on there, so it's an original. Is it the original from this vehicle? No. This is an 87, so it's not the original to this vehicle. I don't remember purchasing this. So, will this little thing right here, is that going to solve the problem? Hey, if you guys like the content, that I'm providing here, why not subscribe? Huh? Why not? I want to get as many subscribers as I can before I die. That's the whole idea. That way there, I live on and so do these videos. Well, I guess what we have to do now is to see if this will take that old wave from that to this nice square wave. Let's see. So welcome to my little mini lab. So that's the reason for this lab coat, is I had to create this little mini lab. If I just went ahead and changed from this, or actually from this to that, and it worked, what good would that do you guys, right? You might not have one in your glove box. So instead of doing that, I decided to learn a lot more about this whole thing. And I created this little pin assignment with the help of the manual, of course. The manual tells you every single pin connector. But, how does this reference to the actual controller, right? How does it work with this? So just to show you that this is the 88, the one with the SMP, and the one that we're going to test is the one that was in the car. So that's the one we're going to test. If I knew how this worked, then I would already know what to be looking for. Or, should I change this out? Or should I not change it out? Should I go ahead and spend all the money on this? You saw how expensive that was. That's just today on eBay, for example. There might be some aftermarket or some phony ones or something like that. I'm not saying that, but you see there. And the same thing with this. Do you just change this stuff out because you have a deep pocket? I don't have that deep of a pocket. I would rather put my money on this for now. It's not that expensive, really. The price of these things comes way down. When I was a kid, I always wanted to have one. My dad would find me at home, taking a stereo apart, right, and having a multimeter. I wanted to know how things worked. I want to know how these two talk together. How does it actually work? Can I see this right here? Can I see it by looking at the waveform? Will that tell me how it works? And not only that, will it tell me what's wrong? So this is like turning the ignition on. The only thing that's different is that we're not connected all the wires. We're bypassing all of that. But otherwise, it's exactly the same, okay? So let's plug it in and let's take a look at what we get. Actually, there's another test that I did not do, in the manual that would also tell you kind of what's wrong. Not necessarily, you might still be chasing this down, so you still need to know, how does it work? How does this controller here work? That's kind of what's important. All right, so let's get into it. So this is just like before, everything's identical. I'm just gonna plug this in. Whoops. Hear it click? That's just like when you first turn on the ignition. All right, now, what do you see? Is there anything that's noticeable here to any of you guys? There's really not a whole lot of difference, except for, that one waveframe is nice and clean, right? Exactly like I thought we should be seeing. But that's how it goes up, right? And it brings it up to voltage, and then it slopes off. Does anybody know why? What? Is there something wrong, or is this intended? That's the question before I reveal it, because I didn't know. So this is exactly how it's supposed to work. This thing here is not working. It's not making a noise. There's nothing going on. This is when you first start your vehicle or turn on the ignition. That's the waveform you should be seeing at the plug. That's what you're looking for. You're looking for battery voltage on both sides, and you're looking for what you think might be correct as far as the square wave goes. The top one looks pretty good, but that bottom one, it doesn't. And you see the bottom one comes on when that top one goes off. This thing is not working until it receives an RPM. So we need to get a tach. But I can test this to make sure that if it receives a tach, right, an RPM, if it receives an RPM, will it turn this on? That is what's important. Just so you can see the pin assignments, okay? Now, the only ones I'm going to deal with today is the one that's dealing with 6 and 7. That's the idle speed air valve, right? That's what we're working on right now. Now, in order for this to function 100%, all these things are going to be talking to this, just like I told you earlier. So you can test this whole thing out, actually, by knowing how it works. Now you have some baselines, at least how this works. And as a matter of fact, that other one that I have works identical. This one, I went ahead and I tested this as well, and this is identical. All the pins, all the stuff, all the numbers I'm going to give you right now is based on the same thing. So I know that these two work identical, so I doubt either one of these are failed at all. So the number I'm going to give you is going to be pretty good. What I'm going to do is I'm going to simulate an RPM as if the vehicle is running. Now, this nice little oscilloscope multimeter thing also has a function generator. Now it only goes to 3 volts, so I think that the one, since I haven't tested this whole complete circuit system yet, I don't know exactly what voltage it sends from the RPM, from the EZL all the way over to here to tell it the RPM, your tach signal. So until I get all that tested, I won't know, but it doesn't really matter. I found that it does trigger at 3 volts, so this little thing can do it. It can't do everything, but it can at least trigger things, and you can see exactly how this works. This is a visual presentation of how this thing actually works, and you'll be able to see how it does this. Check it out. All I'm going to do is turn on my function generator like this, and you hear it. Now, do you see those waveforms? Look how they lined right up. It's very smart design. I didn't realize that this is how it worked. But now you guys know how it works, and this is what you're looking for at the other end of the plug when the vehicle is running. Do you see that? Now that's all messed up, right? your thing's not working. So, you know, you could test this with a multimeter all day long. And even if this was going through, you still wouldn't know for sure, right? You have to get a tach, right? But at least you know that this is what you're looking for as far as your initial start. This is what your waveforms should look like. It should show voltage there, et cetera, et cetera, et cetera. Now let's go ahead and just make a couple of other baselines since there's really nothing else out there. So that way there where you can be at the plug and say, oh, the resistance between these two should be this. Now I'm not so sure we can do that because everything that you see right now is presented to me at the same time. All right, so I'm on a discovery process. And I'm glad you guys are here with me, and I hope you enjoy these videos. You know, make sure you click the bell and all that, subscribe, you know, make comments down below, all that kind of stuff, you know. That's really what it's all about. Share it with your friends. The information that I'm presenting here, I have not really seen anyone do this, right? I mean, it's very cool to see how it works. Isn't that neat? Look at that. To me, I thought it was interesting. It's a fail-safe kind of way to work, right? So it's kind of a really great little design. I was impressed with the design. Now, that's the only circuit we've tested. You know, I haven't tested really anything else, but this is the old one. This is the one that I had in my box. I did this test before already, you guys. This is the old one. This is dirty and everything. The one that's on the vehicle is even cleaner than this. But I have a spare. You know, these are some of the things you might want. Like I said, I'm not so sure you need this. After you see my other video, it shows you how to clean it. Not only how to clean it, but how to test it. This thing's never fully closed and never fully open, really. It's just kind of hanging out. So it's fine adjustments right there for idle. You know, that's why it's important. You know, there's not much more I can do at this point. I'm not going to be able to go over there and start the vehicle and tell you, oh, look, it's all, I can't. If I don't have a tach signal, then this isn't going to work either, but it's easy to test. So everything that I just did right here, the only difference is take your scope, throw it up here and just connect it to the plug instead of like this. That's all. Just don't connect it like this. It's not needed. And then go ahead and start the vehicle and get live data. You know, when you rev the engine, you'll see the difference in the waveform. Trust me, you will see it. Now remember, there's a lot more to this thing than just that. We have all of this, right? Everything is talking to this, just like I said. So right now, this plug is going to be left out, and I'm going to start testing these circuits. So I already know which one of these pins were not producing, so I'm going to just follow that pin and see if I can find where it's missing. Somewhere along the line, we've got something going on. So I'll take care of that, and then I'll start it, and I'll see if the thing works, right? I almost forgot to do the test. You see, guys, I'm getting old, you know. It's not going to be long. And, you know, I'll just be dust like these electronic parts here. So hopefully you'll support my channel, you know, keep my legend alive. All I'm going to do right here, so pretend this isn't here. I'm going to just test the plug like I did over there. Remember when I ran the resistance test earlier? I says, let's just kind of see what it is. Well, this time I'm bypassing everything. You know, as far as wiring goes, but I'm not so sure this is going to tell you anything because I think it's going to depend on what point in the duty cycle this thing is turned off, because this is done with the ignition off. So I'm not quite sure how that all works out. I haven't tested the other one, but if I, you know, I'll test it and I'll put the results right here. So you'll know, just like I know. Everyone should know, right? So again, we're not testing this. We're not testing that, guys. No, we're testing this without the electrical wiring. And all I'm doing, this is with the ignition off. This is how it should look. And I'm doing, well, not how it should look, but this is how this one looks, 66.43. The next test I did was, I says, let's just see what voltage. I'm keeping it the same. I'm just checking the voltage between the 2 pins of that plug, right? Just these 2 pins, I'm checking it, and I just turn on the ignition. Let's see what happens when I do that. You know, if you think about it, it's not much difference, except you're not seeing those crazy spikes. The only way to do it is with a scope. I mean, you could use the manual, because the manual tells you what to do. You can start your engine and do all that kind of stuff. Or you can just pop this out and simulate everything and make sure the device itself is actually working. This next test is also what I did earlier. I tested just the plug, and I turned on the ignition, and I looked at it through the scope. Right now I don't have the RPM running. So this is with the key just on. It's just a baseline for you, because there's nothing published that I know of doing this, so I'm going to tell you, or what I see. It's nice and consistent. The spikes on channel 2, which is the upper ones, you notice it's a slow voltage. That's the upper waveform. And that waveform right there, you notice how it's kind of like a gradual thing and then drops right off. That is your sporadic signal, but you notice how it's always going to fire when the other one is off. So that's kind of how it's supposed to work, but it doesn't really, I mean, it still kind of works as long as you got all your voltage going. Everything should work. But right now, this is not the best test. The best test, actually, is the Tony test, of course. The only difference is when I first did it, I didn't have the plug connected. And I should have. And it should have been a dead giveaway, because the manual tells you how to check it, you know, for milliamps, for example. So this is just a different way of looking at it, and I just didn't have the plug connected, and it would have made the one waveform cleaner, just like it did here, and everything would have worked properly. You would see 12 volt on each side is the maximum and all that. So all this works. I know that every single bit of it works, so I don't have to worry anymore about this. I've traced all this down, and I have no tach signal. And everyone who's been on my channel and watching my videos know from the first start that I was missing a tach. So I have a tach line somewhere within this giant mess. Now, you know that my EZL went bad, and I did a video on doing all of the electronics here as far as ignition goes. I did all that and came down to the final result that I needed a new EZL. Now, the EZL is sending that tach signal to the X11 plug. So I know that that part of it is good. The EZL is great, it's brand new. The only thing is that I don't want to put this in the vehicle right now, because the EZL did short, right? The old one went out. Why did it go out? It really kind of stems from this right here. This is called the N3, right? This is the main plug. You know I have it to the X11, so we see our idle speed control right there. So I'm going through all of this, but ultimately from that to all of that. So this is the circuit that I'm tracing, and I'm looking at it, I'm trying to learn about it and all that kind of stuff, and it's way beyond this particular video. It's a lot better to know how something works rather than throwing money at your vehicle. Just the other day, actually, on the Facebook group, I saw someone said that they replaced all of these components and they still have a high idle. So if you look at it a different way, you don't have to purchase all these different parts. You really should learn how they work and how they communicate with the other parts. Maybe something's not communicating with the part that you went and replaced. That's what I've been doing, right? Educate myself. You shouldn't own it if you don't know how it works. You certainly can't repair it if you don't know how it works. Right, so I'm learning how it works. I wanted to mention that I'm putting together a playlist, and the playlist is about the KE-Jetronics, the components and sensors and all that make up with it, and how to test them and all that kind of stuff, at least how I test them. I'm not going to claim that this is the way you should test it. You guys can test your things the way you want to test them. I'm just showing you the way that I'm doing it. The price of the oscilloscopes these days, these little portable oscilloscopes, are inexpensive. So, you know, why not? And then get some baselines. Looking at a scope, waveform, and stuff like that is a lot easier. It can tell you a lot more. You know, you saw the little static jumps. That's because it didn't have any place to go. You know, that line was just out there. There was no return cycle, and that's low voltage when it's not connected. It's just a real smart design, and that's why I thought I should show it to you guys this way, and hopefully the video is not too long. You know, this is something no one else has ever done, so it's at least that I know of. Maybe there is, I don't know. I'm not going to claim to be the first. I'll never claim to be the first. I'm not the first. So today we went in my mini lab here and did it. I think that's the end of everything on my list. I want to end this. I think that this pretty much covers it, right? Whoa, wait a minute. Yeah, I said it right the first time. The idle speed control valve and the idle speed control valve, no. The idle speed control valve, let's see. I think this covers the idle speed control valve as well as the idle speed control unit. I don't want to look any more into this. I have a headache. I think this pretty much sums it up.